All right. So we've got Loren tonight presenting on software-defined radios.
I don't know how to follow Bob's act, so just
better rhyme.
I got to ad lib for just a minute. If you've ever heard something that just kind of smacks like a punch in the face, that happened to me last week. I was listening to a recent episode of QSO Today. Eric Guth was interviewing a relatively young ham from Tasmania, Australia. And one of the questions that Eric always asks is, what gets you excited about ham radio? What do you think some of the biggest problems facing ham radio are? And there was a really interesting answer to a problem. And it was elitism. And I got to thinking, the context of his answer was, there's a problem within ham radio where some of the old timers, maybe the people that have been around a long time, know an awful lot and perhaps give the impression that you aren't somebody if you don't know something. And the point taken was that it's really critical as hams that we welcome everybody. We are in a hobby of 1,000 hobbies, and everybody has different interests. People have different education levels. And I have a tendency to, and I'm going to do it tonight, slip in some technical stuff just for Bob. What did you call yourself? A techno peasant. Techno peasant. You know what? That is wonderful. Because people have such varying experiences and interests and whatnot. So one of the things, and this, I'm really sensitive to this because in the role of trying to organize presentations for the club meetings, is how do we capture the interest of everybody in the room? That's a problem sometimes. It's just, are we at the right level? So please, if anybody feels intimidated by some of the technical stuff that happens here, don't feel that this is something you have to know. It might be interesting or important to know if you're planning to upgrade or not. Anyway, I don't want anybody to think from the presentations that we give that maybe are technical in nature that we're saying everybody has to understand and has to know about this. We're trying to cater to all levels. So that was my piece. So let's get started. So I'm going to give some background on the SDR stuff. There's a few bits of technical information in here, but basically wanted to give you some ideas on how these might be used. So 2 important rules I learned in my professional life. Never, ever rely on a live demo. Rule number 2, if you're really confident that a live demo will work, refer to rule number 1. But if you can pull it off, it's sometimes worth a try, and that's what we're going to do tonight. Credits, Rocky Mountain Ham University got brought up earlier today. I attended one on SDR, I think it was very early this year up in Denver, and got permission from Ben Matthews and William Schroeder to use some of their slides in subsequent work. I mentioned earlier that this was a small group that we put together. I was in my shack and running a number of computers and doing some different things with it. It's been adapted from that. Raise your hand if you've previously used or currently using a software-defined radio. Quite a few people. Okay. Hands down. Raise your hand if you have an IC 7300 and didn't previously raise your hand. Good. That's the easy mode of SDR. This is a direct conversion. SDR out of the box and does some fabulous stuff because of the fact that it is an SDR radio. Too small to see. There's a block diagram of this radio that might be able to come back and refer to a little bit later. Slightly harder mode. People, anyone running Elecraft? I'm sorry, not Elecraft, Flex radio. Tim's got a Flex. It's slightly harder mode because it doesn't have the software built in. You've got an application that runs on a local computer then that's doing the SDR processing. But the complicated bits from a hardware perspective are built into the radio. SDR, the harder mode, harder, but complexity will vary from easy to pretty much as hard as you want to make it, and range from very inexpensive, an RTL-SDR, which I have plugged in a USB fob. Grab this. SDR Play, $117 currently. These were prices that I checked online this past week. The Hack RF in the lower right is $350. Lower left, the Nuelec NESDR, $595. An AirSpy, $169. FlightAware Pro Stick, like this, which is essentially the same as an RTL-SDR with a few bits modified that's used for a different application, a little less than $70. So you can do this for very inexpensive, and the RTL-SDR is a very powerful receiver. Some other considerations for it is an antenna system as you would any other radio. Better the antenna, the better the performance. External filters can be a good idea. The reason is that these are such wide bandwidth that they just get overwhelmed by the RF environment and can desensitize the signal that you're interested in. Good quality cables, keep your noise down. Faster computers are better, but it really depends on how much bandwidth you're monitoring at any given time. So a little bit of background on SDRs. Most important component, I think, in this is what recently has become affordable and performance-wise started to give the opportunity to do direct conversion, and that's high-speed analog to digital converters. There's a reason that the high speed is necessary. Techie stuff, don't need to remember this. The Nyquist sampling theorem states that in order to reproduce an analog signal from a digital signal stream means you have to sample at twice the highest frequency that you're listening to. So if you want a direct sampling receiver for 10 meters, 30 megahertz, and you have modulation, ignore the modulation, but at 30 megahertz, you have to sample at 60 megahertz. Well, if you're doing it at VHF at 2 meters, 145 megahertz, you have to sample at 290 megahertz. That's high speed, and that's a lot of data that's streaming. So the sampling is performed with that ADC, and the direct conversion receivers didn't become practical until these devices became affordable. Let's see, I guess we can see that. Simple block diagram. This is a block diagram of the RTL-SDR. It is not a direct conversion SDR because you see a 28.8 megahertz local oscillator. So it's mixing this to a lower frequency IF that is being processed. Low noise amplifier like a typical receiver, an RF filter. Local oscillator comes in, a variable gain amplifier feeding into the analog to digital converter, the ADC. There's a term that you've probably heard about an IQ signal. You've heard of an IQ signal? This is where the magic happens in an SDR. Typically, this is performed in a FPGA, a field programmable gate array, but you notice that we have a sine signal and a cosine signal. It turns out that the Q stands for quadrature, I stands for in phase. So the signal that comes in, the I signal, is shifted from a cosine wave to a sine wave. I got a picture of this here in a second, but this is where you now can start to do digital transformation. What are the IQ signals? No test on this. No test on this. I promise.
I haven't had to stand up yet. That's not over my head.
Okay. All right. So I mentioned the in phase. It doesn't matter if the input signal's varying. The Q signal is always shifted 90 degrees. And I'm going to show you why this works here. But if you look at the AM demodulation, these are math problems. These are not radio issues where you're doing filters and worrying about capacitors and inductors. You're just simply taking a voltage level that comes out of that the analog to digital converter and doing math. And if you look at the AM signal, does anybody remember Pythagorean's theorem? If you have a right triangle, you find the value of the hypotenuse by taking the square root of the squares of the adjacent and the opposite vectors. This is the sine. Here's the cosine. The square root of the sum of those is this function x. To demodulate an AM signal, you're just taking using the Pythagorean theorem. Look at single sideband. X of t is simply the input signal. This is really simple to do in a radio, or in a simple processor. No, the FPGA is not where this is being done. This is being done in the software outside of the FPGA. So here's two signals. 90 degrees. The blue signal represents a cosine wave. Sine wave, we're trying to find out what the value of x is because that's going to be the signal out of the SDR. If the value here is 1, the value here is 0. X 1 squared plus 0, square root of 1. The answer is 1. It's just a 1. If you go 30 degrees further, turns out the math is it's 1. You go to 45 degrees, the answer is 1. There's no modulation on this signal. The reason that this works is that if there is modulation here, it means that the next sample, it'll be higher or lower. But the one at 90 degrees is the signal that it was on the prior sample. So there's going to be a slight variation in this, and it's going to track with the AM modulation that happens to be on that signal. That's what the IQ, this is where the magic is happening. Now we can program computers to do the math to demodulate it. That's how an SDR works. Oh, end of the technical stuff.
I'm just glad I got a 7300 and I just got to push the button.
So now, what do you do with this stuff if you're not doing it in your 7300? And why would you use some USB fobs to do some radio? You need some software. So it turns out that the SDR Sharp was the application that was developed for the AirSpy radios, but it works with lots of radios because they essentially work the same with different kinds of bells and whistles. So you download this like you do a typical application, and then you run into problems. And the problem is that these little USB SDRs were developed primarily for digital TV in Europe. They had that a standard that was broadcasting digital TV long before that happened in the US. When you plug this in, Windows is really smart. It loads the driver that will make that work. Unfortunately, that driver doesn't work for these applications. So there's a process, and I'm not going to go into that because I got a bunch of things to cover. And but there's YouTube videos to do it. You basically have to blow away the driver that loads automatically and replace it with one that's part of the download. So it's not too bad if you follow the instructions. So what do you do with it? Well, FM broadcast. And it's smart enough to know that, if anyone could tell, that's Led Zeppelin music on KKFM that I recorded, or at least took a snapshot of. But all kinds of different schemes here. This is automatically, it knows from that frequency band that this is a wideband FM signal. So the bandwidth is 200 kilohertz here for that signal. And you can tune this just like a radio now, and listen to different radio stations. It's kind of interesting to see because a lot of the FM stations have subcarriers where they have lower fidelity adjacent channel or channels that are actually broadcast along with their primary signal. Here's a 2-meter receiver. Frequency 145.13. This is the Colorado Connection repeater for Colorado Springs. And, so I've got a little bit wider bandwidth showing here. I narrowed it up, and looks like somebody might be overmodulating a little bit on that signal. So here's something that you can do. You can actually look at your own signal with an SDR by monitoring the repeater, because you're transmitting on a different frequency. And I might be able to illustrate that here in a second. We'll see. Wow. Let's see if we can. Well, according to my rule, it probably won't, but we're going to give it a try. So, no device selected. I'm going to come up here to, this happened earlier today, and I panicked, and I think I figured out what was going on. Is that I have no RF gain for this, and I'm going to turn on the AGC, the automatic gain control, and no device selected. Let's plug it in. This is why I prefaced this whole thing with my rule. One more thing. Let's look at this one more time. I'm glad I took pictures of everything so I could at least show this. Doesn't work.
Thank you. I'm not the only one.
No, there's a good reason I wrote that rule, and I wrote it down before I even tried this to see if I could make this demo work. So another thing, let me back up a second. Why would you use this? And one of the things that intrigued me is I don't like to sit and listen to this in scan mode. And if I've got access to my local, if I'm at the computer and I want to monitor where's the activity, I can set up to monitor pretty much the entire 2-meter spectrum and actually visually see where signals are coming in. I can see the activity on various repeaters and then go and listen in. And I don't have to be sitting in scan mode and have it just keep shuffling around. I can choose how I want to use it and what I want to listen to. And like I said, monitoring your own signal is a pretty cool feature as well. So I mentioned this is essentially the same thing as this RTL-SDR repackaged. I'm going to actually try another demo here in a second. Does everybody know what an ADS-B signal is from aircraft? Anybody not? So the FAA requires commercial aircraft to have transponders, and transponders are sending out signal reports of their location, their altitude, their speed, heading, bits of information like that, so that they can identify for traffic control the aircraft. Well, with one of these tuned for 2 bands, frequency band of 978 megahertz and 1090 megahertz is where they're being broadcast. And here is from Flight Radar 24. This was a image I took this afternoon online. I'm not receiving all of these signals. This is a compilation of signals from all over the world, people listening in to this. I don't use Flight Radar 24. I have, but I use software anywhere from FLIGHTAWARE. And this is a screen capture of local aircraft that I was monitoring. And 30 total aircraft, 29 of them currently giving positions. And I'm able to go and click on those aircraft and get identification. And then here's a picture of statistics that I've been collecting, and it keeps track, and you actually get rankings comparing you with what they are called feeders. So if you're feeding this information that you're receiving in. This is essentially the full setup. I've plugged this into a Raspberry Pi. This is a bandpass filter. So this eliminates the local FM, KKFM from overloading the front end of this. So it's more sensitive in the band. And this is a homemade antenna that I have up in my attic. That is nothing more than an SO239 bulkhead connector with a short wire that's tuned for 1090 megahertz and radials. And for some reason, having them bent down works better than having them at 90-degree angle. So I have this in a PVC pipe that's nailed to a rafter in my attic. And if we go back to this, it shows where you're getting your reports from. And virtually all of the reports are in this quadrant, which kind of tells you I've got big piles of granite that are around my east and north and west, but I can pretty much see to Amarillo. in that direction. And I can actually receive the signals from aircraft south of Amarillo, almost 300 nautical miles from home.
With that small antenna.
That one that I pictured, exactly. So I have a Raspberry Pi running in my attic 24/7 and just collecting and feeding them. So benefits of doing this. If you're a feeder, you get their business accounts or professional accounts. You don't have to pay for that. And there's some nice features if you track an aircraft just for the purpose of, is my actual plane that I'm going to get on inbound like the airline actually is saying it, or I can go look and verify that for an actual fact. Look up in the sky, see a contrail. I can go in and identify what that aircraft is in many cases. And I didn't write it down here, but what's actually kind of fun is see if you can find something that actually isn't reporting in. You can actually track the Air Force One as it flies across country because you see in that map, you can see a separation of aircraft. And so across the US, all of a sudden, it's like a tunnel. And why would that be happening? Well, a plane that doesn't want to be tracked and aren't allowed to fly close to is probably there. So there's some fun information that you can get out of these.
If Air Force One is up, it'll usually on ADSB exchange identify as Air Force Two to screw you up.
So I'm going to stop the share that I did and try to share another screen. So this is a live picture of that Raspberry Pi that's operating at home. Currently tracking 27 aircraft. There's one here that's just a little bit north of Amarillo. Local aircraft here. So web server and log into FLIGHTAWARE and you can see what's going on wherever you happen to be if you have internet access. So I'm 1 for 2.
Just as an aside, when the cadets are flying, you can also see their aircraft.
That is true. I frequently track their aircraft that are pulling the gliders that are circling around over my house. So I want to talk, I worked all week to try to make this demo work. But I knew coming here tonight that it wasn't going to because I have a complicated router configuration of my house where I've got a gateway and 2 separate virtual LANs, and doing port forwarding through this thing is a real pain. I'm going to need some help with this. But pardon me?
Just give me a call.
You're on, Bob. So this is also something that I have periodically running at home on a Raspberry Pi. It is a Linux-based image that you can download, load into the Raspberry Pi, and it's a very, very powerful SDR, which should be accessed from any computer with web browser if you have the proper permissions and firewall holes in your system at home. Here's a picture of the setup. I've got a 3D printed case with a fan built in, and here's my RTL-SDR plugging in and power and a LAN cable, and I'm operating this headless. You don't want to operate it headless while you're setting it up, but it's download the image and load into the Raspberry Pi, set it up with your monitor, keyboard, and mouse, but then start running it remotely, and I can log in from any computer that has access on that network. Lots of YouTube videos to help you. I like this one because it seems to have more features than the SDR Sharp that I showed you. For one thing, I'm able to configure the receiver to give me more bandwidth. This is where I want to see the entire spectrum of the 2-meter band, and I'm using this as my scanner of sorts. Simple setup up in the upper right-hand corner where you select your center frequency, you select your sample rate, you select a starting frequency, set up your RF gain that you need. And then you just select the receiver that you just set up. You can configure many different receivers for different functions. And in this case, what does it say? It is a 70-centimeter repeater right now. But if you notice right down here, that's circled, the decoders that are available: FM, wideband FM, AM, lower sideband, upper sideband, CW, FreeDV, if anybody knows, there's an open source codec for digital voice, DRM. So this will do digital radio decoding. And I'm presuming that if you happen to have access to other decoders, you might take advantage of those. Set up squelches like you do with an ordinary radio. Yeah, here's where I was hoping to show you. If you have a dynamic DNS that will route back into the server that you've got, you should be able to access it from any place, even if your IP provider is doing dynamic IPs and changing them on you periodically. Why would you do this? Well, I mentioned observing the local repeater activity without needing to scan. Listen to activity from your recliner with a notepad or your iPad, and but you don't need to configure it for the public access. So I use another SDR 100% of the time when I'm operating in HF, and I'm using an SDR Play and a software called SDRUNO with my FTDX 3000. Simple configuration. I've got my FTDX 3000 with here's the antenna input with a CAT cable, the CAT interface that is connected to my PC. There are two signal outputs on the back of that radio. One is called the IF output, and then there's an RF output. I use the RF output because it's wider bandwidth. The IF is limited by the radio, but this gives me the ability to look at the entire band, and I'll show you some pictures of that here in a moment. To get it working, SDRUNO, I use Log4OM version 2 as my primary logging program, and the software talks to each other. So I'm reading the frequency that I'm operating at on my logging program, and when I click log, it captures all of that information. But here's a picture of the setup. This is a 20-meter band. There wasn't a whole lot of activity when I took this snapshot. Sunspot cycles up a good bit higher right now, so there's a lot more activity in the single sideband portion of the band. But I can click on a signal, and the radio automatically tunes. to that. It knows it knows that it should be in lower sideband versus upper sideband. I can choose to actually listen to it, although there's a slight delay from the radio speaker when doing this. But I'll tell you what, on an FTDX 3000, the waterfall is pretty much useless. This is gorgeous. I've got this on a 26 or 28 inch monitor, and it's real easy to find signals and tune with this. So how many are doing this with an SDR plate? Chip is, Greg, you have done
Yeah, I
this.
did it before, but then I upgraded the radio.
So did the radio have a 28 inch monitor for?
No, but it's touchscreen.
True, you can do this with a touch screen if you have a touch screen
This
monitor.
worked great for the FTDX 3000.
So it works with virtually any radio. If you don't have a switched signal coming out, which means that you do not want to put a transmitted signal split into the SDR, or you will release the smoke from it.
I leave my SDR play on all the time, so I can look at my transmitted signal. I just have a telescoping antenna on that that's offset vertically from my 500 watt, 20-foot antenna on the tower. And I find that gives me plenty of separation so that I don't overdrive the SDR when I transmit, but it still lets me look at the whole band and do exactly the things you're talking about.
So with that whip antenna, you may not be seeing signals that you would be with your other antenna.
I'm amazed at how sensitive the SDR play is, especially the newer ones that have the filters for the broadcast bands. Their noise floor is.
These are remarkable radios, and I think
$200 is a better spectrum analyzer than the $50,000 spectrum analyzers I was selling for HP, which is painful.
especially for anyone who paid that kind of money for one back in the day.
Yeah.
Exactly. So SDRUNO and OmniRig provide rig control. Oh, I was going to say, you can still use it if it's connected to the same system. I think I put in another block diagram, but you need a TR switch. You need to have a very, very fast TR switch that will actually detect the presence of RF coming from the transmitter, and it will shut it off anything that's going to the SDR.
MFJ has a TR switch that seems to work very well and it's very reliable. It's $140 or something like that. I just to try it, I bought one of the AliExpress or Banggood switches for $50. It works, but having opened it up and looked at it, I am not comfortable with it trying to protect my SDR play.
Anyway, caution required if you're hooking it up to something that doesn't have a switch, that isn't switched right out of your transmitter. As I said, I seldom touch the tuning knob or the mode button. I tune with mouse clicks and fine tune with the mouse wheel. Yeah, I mentioned the software. All right, the last subject for the evening is called GNU radio. This is really cool, but you gotta be pretty geeky to get into this one. So it is a software radio ecosystem, open source software development toolkit providing signal processing blocks to implement software radios. In essence, what you're doing is you're creating the application to decode a software defined, or to decode a radio signal. You're creating the application. It's written in Python. Now, the good news is there is what's called the GNU Radio Companion. It's a GUI, and I'll show you that. Again, lots of YouTube videos about this. But I showed you a 2 meter narrowband FM receiver in, the waterfall and the controls to do that. I built this one from scratch that does essentially the same thing. You're taking your source, which is your software-defined radio. I put in a low-pass filter. I've got a squelch. Here is the actual narrowband FM receiver and audio output. And you fine-tune these. You fine-tune these things. You set the rate at which you're sampling. You get lots of data. You downsample information. You're using components in here, and you got to know what you're doing. But the really cool part is that even if you don't know what you're doing and you're starting to put stuff together, you're not going to break anything. So you're not messing with the hardware. You can do things. Man, that sounds terrible. Go in, change the gain, change the bandwidth. Oh, shoot, I wanted to listen to a narrowband FM signal, but I only have 5 kilohertz instead of 25 kilohertz. Well, you can hear the difference when you build that radio. And this is drag and drop. So there are probably 100 different modules that you can put together. And the other cool part about GNU Radio is that you can actually build a transmitter. You can build a transceiver out of this system if you've got the hardware. The $29 RTL-SDR dongles do not transmit. That's going to raise the complexity, obviously. Here's a broadcast receiver that I built that I could actually tune. So I pre-programmed in stations, and I had a little dial that on the screen, and I could tune to different radio stations. So what I've presented here is from very, very basic, simple stuff because the applications are already built, and it's pretty much follow instructions, and you can get a radio operating for, as I said, $30. And if it had worked, I've just got a little magnetic whip that I put on the top of the car periodically that I use. I just slap it on a steel beam that I have in my basement, and I can get anything south. I cannot hear N0XLF. I actually can see the signal, but I have no quieting in the radio when I'm listening to it from my location. But I can plug it into the antenna on the roof if I'm not planning to join the net. And just, I did last week listened into Logan, you were on the net last Monday, and I was listening to it on one of my SDRs. That's the gamut of, from simple to complex. And any questions?
Wow. What a question. I asked Doug in pretty deeply about 2 years ago or something. And one of the things that struck me was that the transmit side is not well supported. I really enjoyed playing around with that Open Web RX because decoders, and you got this stuff there. I saw stuff like DMR decoders, 5 decoders, Open Web RX. That's awesome. I enjoy this.
Yeah, they were there. I didn't mention them, but
on the transmit side, I was seeing that the hardware is lacking. For example, there's like the Hack RF1 and the Lime SDR that have such low power outputs you can't drive any off the shelf amplifiers. Just basically that. And then software wise, the whole point again is write modulators in software and not have to play around with circuitry. I didn't see any encoders for DMR, 25, C4FM, and D-Star, and stuff like that. So, like I said, that was a couple of years ago I last dug into it. I'm wondering, have you seen any activity coalescing around creating transmit capability as we have enjoyed receiving?
I have not gone into, I haven't, but primarily because I haven't had time, and it's on my list, but it's down the list a ways. So no, I can't respond to that. Yeah, I think I watched a YouTube video maybe sometime a year ago or so of people that were working on it, but I don't have any info.
Just, I think it would be awesome if, you know, a year from now or 2 years from now, we're all sitting home with our laptops or tablets or something like that, and we can talk on CUFM repeaters, DMR repeaters, you know, all of the above repeaters, just by clicking different modes on our SDRs. I think that would be something fantastic.
That might happen sooner with FreeDV than with the license protocols that the big boys are using.
I actually contacted the SDR Play people about a year ago about transfer capabilities. They're wonderful, and had a pretty long conversation with them. They said the basic problem is the potential for unintentional abuse is so high that the liability is just dissuading anybody from even trying right now.
So anyway, my parting message is go have some fun, experiment, play around with this stuff. It's not a huge investment, and it's pretty remarkable stuff that you can find to do, and might learn something of interest. And if you're not, I hope it was moderately interesting. Thanks.
Awesome. Thank you, Loren.